This video is to help you guys review for your quiz, to know what content is covered on your quiz, things that you need to know. You're welcome to look back at any video lessons we've done over this week, as well as any practice in class that we have done. All right, first of all, something that we talked about in our last unit and something that was expanded upon in this unit was that matter comes in 3 states. There is a 4th state of matter, but these are the 3 states that we use and manipulate in chemistry. Now, solids have low kinetic energy, so kinetic energy increases as we go towards the gas state. It is low kinetic energy with solids. However, particle forces, that is the forces between the particles in a solid, particle forces increase or are higher in a solid than in, say, a liquid or a gas. So this is the forces of attraction between the particles of matter. It is low to non-existent in gases, but it is high in solids. The particles are very attracted to one each other, giving a definite shape and definite volume in solids, unlike our gases. All right, also to know in terms of solids, liquids, and gases are the phase changes. There are a number of diagrams we went over. There are 6 phase changes. 3 are endothermic and 3 are exothermic. We also looked at a phase diagram as well, where you can basically see the different states of matter, solid, liquid, and gas, that are indicated on a phase diagram based on temperature and pressure. All right, so just kind of knowing what those look like, or that one of those looks like. Now, what else we covered in this unit was the properties of matter. Major categories of properties are physical properties, which are observable or measurable, and then you've got chemical properties, which are only observable through a chemical reaction. It will actually chemically modify the matter. So chemical properties are things like flammability, combustibility, corrosiveness, the reactivity with other chemicals and other substances. Physical properties are things that are observable or measurable without changing the chemical identity. So this could be something you measure, like temperature or mass. It could be something that you observe, such as color or texture or smell. Now, physical properties are further broken down into what are known as extensive properties of matter and intensive properties of matter. Extensive, intensive. The difference between extensive and extensive properties change based on the amount of that matter, the size of the sample, the amount that you have. So mass, volume, size, potential energy are extensive properties. Intensive properties are going to be the things that do not change based on amount. Regardless of the amount, it's not going to change. Color doesn't change just because you have more of something. The density doesn't change. The smell doesn't change. The texture doesn't change based on quantity. The melting point, boiling point, freezing point does not change based on how much you have. So knowing the difference between extensive and intensive. Now, so something that we also did was we took the density cubes and practiced measuring mass, volume, and density. Mass is going to give you the amount of matter that something has. We use an electronic scale. This is where you're going to see grams, or you could see kilograms. Okay, this is mass. Okay, it is the amount of matter that a sample of matter has. Volume is typically what we refer to as the size of an object. So how much space, how much 3-dimensional space an object occupies, object takes up, all right? And if it has 3 planar sides, like the density cubes, we can actually measure out length, width, and height. And since they were cubes, they were all the same. But length times width times height is a way that we can get volume. We can also, and this is how we do for solids that have 3 planar sides. If it is a liquid, we can simply just take that by measuring it in a graduated cylinder, beaker, that sort of thing. Now, mass of an object divided by the mass of an object divided by its volume is density, okay? So density is a ratio of mass to volume, and density is actually intensive, while these other two, mass and volume, are actually extensive. But density is a ratio of the mass to volume. So it's always how much matter I have per unit of space. So mass divided by volume gives me density. All right, now, other than this, something that we talked about in this unit so far was that when you measure, you take measurements, you have data, you can actually analyze that data and describe that data using two terms known as accuracy and precision. So remember that accuracy is how close something is to the accepted or true value. So accuracy has to do with how correct or accurate your value is. So how correct your measurements are. Okay, so this is accuracy, whereas precision is not about accuracy, it's about consistency. So precision is how close a set of measurements are to one another, how close a group or set of measurements are to one another. So remember the bullseye example, the target example, and then the example that we had on the back of our worksheet, how close a group of measurements are to one another. All right. All right, that's precision. So there is a difference. So accuracy is how close your measurement is to the accepted value. So if the density of aluminum is 2.7 and you get 2.8, you're pretty accurate. You're really close. Now, if the density is 2.7 and your measurements are 2.9, these are three different measurements, and then 3.7 and 1.2 are your density values. These are not precise or accurate. All right, to be accurate, you have to be close. This one's kind of close, but this is not what we would call precision. Precision would be where you got numbers or values that are all very close in value to one another. Okay. So something we worked on and practiced on in class this week. Also, so what more recently we've been talking about yesterday and today would be the classifications of matter. Basically, there's two major categories. We've got substances and you've got mixtures. Okay, now substances are chemically pure. That means, mixtures. Substances are made of all one particle type. If it's an element, that means that all the atoms are the same. If it is a compound, that means that the matter is made up of all the same molecules. All the same atoms. Compounds are made of all the same molecules. Okay? So, and examples, we gave those in class. Compound elements would be any of the elements on the periodic table. All the atoms are exactly the same. Compounds are going to be a chemical combination of two or more atoms, such as water, H2O, CO2, carbon dioxide, sodium chloride. Okay, this would be two or more elements that they are chemically bound in a molecule, and so all the particles would be water particles or carbon dioxide or sodium chloride. Mixtures, though, can be either homogeneous or heterogeneous, okay? So mixtures so here's the thing with these. So mixtures are made up of more than one particle type, and mixtures, if they're homogeneous, then that means that they're going to look like a pure substance, but they're not, okay? So in class with the density cubes, we had the brass density cubes. That's actually a mixture of zinc and copper atoms, but they appear to be pure, all right? But they're not. They're not all one particle type. The air inside of a room seems to be pure, but it's not. It's got multiple types of gases in it. Salt water is going to look just like water. It's going to look clear. It's going to be up here all as one thing, but it's actually salt molecules, sodium chloride, and ions, and then water molecules all mixed together. But they homogeneous mixtures are going to appear pure, but they're not. Now, heterogeneous mixtures do not appear pure, okay? They are not evenly blended throughout. There's going to be an obvious particle difference. So examples of heterogeneous mixtures are going to be any type of juice with pulp, Rocky Road ice cream, mint chocolate chip ice cream, cookies and cream ice cream, so chocolate chip ice cream, I said that, chip ice cream, many different types of foods, granola bars, those are going to be heterogeneous. Even concrete, and there was some people like, well, concrete, it all kind of looks the same. Yeah, but you can tell by its makeup and its texture that it is made up of more than one thing. These things look chemically pure, but they're not, okay? These things are going to have, it's going to be obvious that it's made up of more than one particle type. Now, for anyone who's wanting extra practice with being able to discern between pure substances and mixtures, there is actually some extra practice that I have posted on to Schoology as well that you can look over, and answers as well to check. Now, this is the one thing that we haven't covered in terms of our chapter on matter, the different components of matter, and we are actually going to start this. This will be after your quiz. We will start on this and into next week and actually have a lab over it as well. However, these things are things that have been covered so far in this unit and are fair game for your quiz Friday.